A lot of people have been reaching out about SIBO the last couple of weeks since our last video. And prior to that, a lot of people were reaching out about an autoimmunity that was unresolved. And so one of the big things that I find is that, and for those of you who don't know what SIBO is, SIBO, small intestinal bacterial overgrowth, it's a digestive disturbance whereby one of the trademark features is within about 45 minutes, or about an hour after a meal, I should say, person starts getting bloated and gassy and severe digestive disturbance, possibly diarrhea or constipated. They tend to do really poorly on probiotics, and certain foods tend to really trigger them. For example, FODMAP foods. Okay, and so most of the people that contact us about SIBO have already done the FODMAP diet, or the diet that's supposed to be best for SIBO. They've done different remediation programs, like either antibiotics to kill the overgrowth or herbal antibiotics to kill the overgrowth. And they've tried probiotics to kill the overgrowth, and those things just aren't working for them. So what we do here is we try to investigate, why is that? What are the underlying problems that contribute to SIBO? And one of them we see often is autoimmunity, which is our first video together, Jess and I. And certainly SIBO can contribute to unresolved autoimmunity, and unresolved autoimmunity to the small intestine or the stomach or the large intestine can contribute to unresolved SIBO. And so they become these loops that we have to break. But today I want to talk about a whole other story. And most of the people that have a digestive disturbance, a lot of the doctors are really focused on their digestion, and that makes a lot of sense, right? I mean, they're bloated after they eat, they have undigested food in their stool, they may be constipated, have diarrhea, they've been told they have irritable bowel syndrome. That's their diagnosis. It's like, thank you very much. Yes, I know my bowel's irritated, okay? They may have tried special diets like the SIBO or FODMAP or GAPS diet. They may have tried an autoimmune paleo diet and either gotten better and their symptoms came back, or they got worse on those diets. And when I start to investigate these cases through a process we call here at Atlas a case review, which is we take a look at all of the labs they've had done. We get our hands on as many chart notes as they've had that we can get our hands on. We have them fill out a narrative, a personal narrative and a medical narrative. And we kind of pour through all their information and say, what actually happened here? Why did they end up with SIBO or autoimmunity or this digestive disturbance like celiac, for example? So one of the big stones that I find is unturned is the whole concept of how the brain actually regulates the bowel, okay? And so we've all heard of people that go to a medical doctor or another type of practitioner for depression or for anxiety, and they've tried the drugs for depression, they've tried the nutrition for depression, they've tried the brain drugs, the brain nutrition, and nothing happened, okay? The depression just is not resolved. But then they went to see somebody like Miss Flanagan or our nutritional therapist, Nicole, and they go through this gut restoration program and they go through a special diet, and voila, their depression goes away. They start eliminating better and they start feeling way better about their lives. We've all heard this story, right? So that's the classic gut brain problem, okay? The other side of that coin is the person with chronic bowel disturbance like SIBO or Crohn's or celiac or irritable bowel syndrome, whatever, who actually has a brain primary issue. And so what's happening is, imagine the switch in the brain, and to the left is called the sympathetic nervous system. This is our fight or flight nervous system. When this gets activated, we want to run or we want to fight. And so what we do is we send all the blood to our shoulders and hips and our parts of our brainstem that alert our stress response so that we can get ready for that, okay? The blood leaves our digestive organs, it leaves our small intestine, it leaves our stomach so that we have resources to do this other stuff. So by definition, there's really not much happening there. Now, the converse of that on the right is the parasympathetic nervous system, which is the rest and relax. This is like, I got home, I'm having a great day, I'm having a meal with somebody I really enjoy spending time with. I'm happy and I'm eating my food. It tastes really good and my food digests very well. It goes into my intestine. It gets absorbed very well. It goes into the large intestine. It gets eliminated really well. Some of the things that my body takes in get distributed evenly, and my liver detoxifies the rest very well. Very nice. Okay, that's a parasympathetic response. Now, does it make sense just from that story that somebody who has a dysautonomia, meaning they're stuck one way or the other, how that could be a problem? Most of the people that I see with chronic bowel disturbance that have not had resolution to their issue have a strong polarization to what's called a parasympathetic dysautonomia, or excuse me, a sympathetic dysautonomia, meaning they're stuck in fight or flight. And so they go on the herbs to kill the bacteria, and the bacteria gets killed, okay, but there's no blood in the intestines to give it good motility or good tone. And so then the stuff goes in the intestines that isn't digested very well because they're stressed out, and then it just rots in their intestines or it doesn't move through, they're constipated, and it just comes right back because the brain was stuck in fight or flight. Does that kind of make sense to everybody? I mean, that's a really big deal. And so in functional neurology, what we do is we look at the brain and we say, is there a system that's offline? How do we measure that system with exam or other diagnostics? How do we quantify or qualify that? And then can we intervene and see the change? And so one story that relates to an excess of activity in one circuit in the brain that can contribute to this high sympathetic tone is related to the amygdala. And that's what I want to talk about today. The amygdala is the part of the brain that tells you you're either in danger or you're safe, okay? And so it's kind of where vigilance lives. So if the amygdala is really turned up high, for example, if you're walking down a dark alleyway and you're by yourself and you're in a strange country and you really don't know where you're going and you're lost, it's the middle of the night, you can't see very well, and you hear noises, your amygdala is already amped up telling you you're not safe. So say I happen to be in that country and I walk up, I go, oh, hey, that's so-and-so, and I see that person, I go and I reach out and I touch their shoulder, they're going to freak out until they look and they can see my face, and then they have facial recognition that goes to the amygdala and says, oh, he's a good guy, you're okay. And you might calm down instead of just like keep screaming, okay? So that concept is so important because there are internal mechanisms that upregulate the amygdala. For example, an easy one for some people is caffeine can upregulate the amygdala. For some people, it downregulates it. And there are external things that do that, okay? And my goal today was to help talk about some of the connections of the amygdala cortex with other aspects of brain so that we can kind of get the story going about how we can get stuck in this dysautonomia or this sympathetic overdrive, which, by the way, will completely deplete the adrenal glands over time. Okay, and I'll show you a mechanism of how that works. Okay, so let's say a person drinks like 4 cups of coffee and they get jittery from that. What is that jittery? What's going on there? Okay, they start drinking a bunch of adrenaline, basically. They release epinephrine, norepinephrine in their brain so much that their amygdala activates, and now they're a little jumpy and they're a little shaky, and it's because they've activated their fear response. So to go backwards just a little bit, the standard of care right now is to be very, what's called loculated. And I just got to attend a great seminar taught by one of my favorite teachers, Dr. Brandon Brock, a brilliant clinician. And he was talking about how we've all become very loculated in medicine right now, meaning in our own little cell, our own little cage. And so you'll see a cardiologist for this, an endocrinologist for that, a GI specialist for this, a head doctor for depression, or maybe you'll see an alternative doctor, but they specialize in chiropractic, or they specialize in alternative medicine and Chinese medicine, or they specialize in naturopathic medicine, or they specialize in homeopathy, whatever it is, but they kind of try to fit you into their model And the flexibility and the well-rounded adaptability and integrated approach is still missing. It's emerging, but it's still missing. And so it's very easy to diagnose somebody with irritable bowel syndrome and to try to put somebody through a protocol. But a really important question with somebody with irritable bowel is, hey, do you have any anxiety? Do you have any phobias? Are you tired? How are you sleeping? How is your attention? How is your memory? Okay, and these are more neurological sequelae related to functioning of the brain that we don't necessarily associate with bowel dysfunction. So when I go through my case review and my history and my exam, I start asking people, okay, well, we understand that you're having 2 bowel movements a week, but are you an anxious person? Do you have anxiety? And then if it's anxiety, is it generalized anxiety? Is it social anxiety? Is it performance anxiety? Is it PTSD? And there's different areas in the brain that are responsible for social anxiety versus generalized anxiety, for example. And so in my mind, I can start mapping out where is the problem neurologically that's contributing to this that maybe hasn't been addressed yet, okay? So it becomes very, very important to be able to map this stuff out. And so the amygdala is located here in the temporal lobe, okay? And we're going to talk about some of its different projections here in a second. So the amygdala is basically where our fear response is generated, okay? And so a great book with like all these pictures in great detail is something called Stephen Stahl's Essential Psychopharmacology. And I'm literally just going through some of the diagrams in this book so I can keep track of this really well. And when we get to understanding these different circuits, it all is going to start making a lot of sense to everybody. It's pretty cool. So I was really proud of the diagram or the picture that was used for this event. And I had somebody very clearly say I was a real big nerd for liking that picture and that a lot of people wouldn't relate to that picture. And but I left it on there. So anyway, here's a little drawing of that picture. And okay, so when our amygdala gets upregulated, it says, okay, I'm not safe. And so it starts directing activation to different aspects of brain to carry out different processes, okay? So for example, the amygdala gets upregulated. It says, I am afraid. It sends a signal to the orbitofrontal cortex and to the anterior cingulate cortex, and this is where we feel or process the emotion of fear. Now, the orbitofrontal cortex is important for impulse control. So like say like you're scared out of your mind, you're probably not going to mind screaming and running. Whereas what if you had an upregulated amygdala and you hear a noise and it's annoying and you just want to scream at somebody to shut the heck up, chew with your mouth closed, right? Whatever. But your amygdala is so upregulated that you might not be able to control yourself from saying that. Or you might just get up and leave instead of actually just, dealing with it, okay? Or if it goes to your anterior cingulate cortex, this is where we make decisions about what is true. Okay, we look for errors. So for example, and this is happening a lot in the news right now, right? And this isn't a political discussion, but there's a lot of talk about, let's say you're talking to somebody and they're like, hey, this is what's happening. And then you look at the pattern of behavior and then you look at their actions. And you're like, your actions don't actually match what other people around would consider to be reality. And so you see this error. And then because you see the error, you're like, oh, hey, amygdala, I'm seeing an error. So we should be a little nervous and a little afraid of this situation. Well, if the amygdala gets over activated, it can send a signal to the anterior cingulate and say, man, you might start to see things that are actually not errors. You might look at somebody's face and you might suddenly think that they are grimacing at you, or the blank face, they actually mean something harm, where they're actually just relaxed and they're just looking at you. And so you may start to miscalculate their intention and things upregulate, okay? And that's where we generate the affect of fear, okay? We start to see these different things in the history. Now, the amygdala can also project to something called the periodontal gray. And so this is the area of the brainstem that says freeze. So we've all seen a rabbit or a deer in headlights. They just stop, okay? And so this is how it plays out in humans. Humans that are like being traumatized, they'll just freeze. And like they'll sit there, it could be a trained martial artist, and then they get put in the situation. They're so stunned that they just freeze. The amygdala is like, I'm in danger, and they just freeze. That's a very extreme version of that. A milder version is somebody who is becoming more and more agoraphobic. They don't want to go out anymore, right? So they're like, I think I'm just going to stay in tonight. I'm just going to hang out at home. And thanks for the invitation, but I'm not up for it. And, are they actually being introverted, or are they actually slowly but surely coming to threshold with their amygdala and their periodontal gray is getting the stimulus that I am not safe if I go outside. I am not safe if I go to this party. I'm going to have to talk to people I don't know. It makes me uncomfortable. And they're not able to regulate that fear response or the anxiety from that, and now they end up staying home. Okay, it's a very common thing. We see people that have agoraphobia, where they have these subtle social phobias or performance anxieties, and they just freeze at that moment, and they don't want to go out and do their thing anymore, and it becomes a big deal for their partner, for their spouse, and that's a key part of the history, and we can actually work with that neurologically, okay? The next thing I want to talk about is the endocrine output of fear. So the amygdala can project to an area called the hypothalamus, and the hypothalamus is kind of just north of right between the eyes, deep in the brain. And what it does is this is where we have our cortisol response. So the amygdala says, I'm afraid. It goes to the hypothalamus, and we release cortisol, which is the hormonal equivalent of shrinking all of the blood from our intestines and stomach, because now we have to be in this hormonal fight or flight response. And that could last anywhere from 4 to 8 to 16 hours. Just one cortisol dump, okay? So we can see how, for example, if somebody had whole grain food for breakfast and like essential fats, like really good food, but too many starches, and they get an insulin surge, and then they get high cortisol, and that high cortisol projects to the amygdala gets afraid, and then it projects back to the hypothalamus, more fear, and then that fear creates another situation where they have an exaggerated, expanded cortisol stress response. And there's just no way we're going to be able to give that person probiotics and give that person digestive enzymes, and that's all we do, and it's going to solve the issue, because there's literally no blood in that area for that person to heal. Are you starting to see where this all fits in? Okay. Now, if we go to the peribrachial nucleus, this is where we start breathing. So people, when they're afraid, they're like, okay, and that's very easy to see. But let's say somebody comes in and one of the key history findings there is, I can't take a deep breath. I can never get enough air. And I just feel like I can't get enough air. And that could be the amygdala being upregulated in a sympathetic tone, going to the peribrachial nucleus and basically saying, this isn't going to happen. There's like a glass ceiling there, okay? And we start working with the person with the neurological basis of calming the amygdala down and working with brain chemistry instead of gut chemistry, and we see them be able to take a deep breath, and it can happen very quickly, okay? And the next area, one of the last areas I want to talk about, is the locus coeruleus. This is where we release epinephrine and norepinephrine, okay? So this is the autonomic output of fear from a neurotransmitter basis. The other autonomic output, the hypothalamus, is more hormones. We shift to cortisol dominance, and we can lower our estrogen and testosterone and progesterone, and that can contribute to infertility and weight gain around the middle, sugar cravings, and all that stuff, okay? But when we have a neurotransmitter type output, it is a faster response. It is usually a stronger response. So heart rate might go up over 100. They may get constriction of blood vessels, so blood pressure goes up. They may get cold hands and feet, and you see, like, you look at their palms, and they're like blotchy white and red, okay? And their hands and feet are constantly cold. And this is the person who has an elevated locus coeruleus. This is also the area that might be overstimulated by caffeine, which can then upregulate the amygdala, or the area that can be overregulated or upregulated or overstimulated by exercise, like CrossFit, for example, which is really great for some people, but for some people it upregulates the locus coeruleus, which then fires into the amygdala, and then you get this systemic switching over to a sympathetic tone that now pulls blood out of the intestines. They get leaky gut because it doesn't heal. They get food sensitivities, which contributes to local inflammation. That local inflammation in the bowel gets systemic once the heart beats. That inflammation goes up to the brain, which makes the amygdala more upset because there's more stress hormone and more stress neurotransmitter and more excitotoxic neurotransmitter upregulating the amygdala. You can see how you can get this problem where if we're loculated and we only look at one aspect of this, we only look at the intestines, we could be missing the boat on this whole thing. If we only look at the brain and we don't understand how the gut inflammation is upregulating the parasympathetic tone and the sympathetic tone and making that dysregulated, I should say, we could be missing the boat on that. So for complex cases, we're finding that a well-rounded practitioner and an approach that looks at many different aspects of physiology instead of putting somebody through a protocol might be a better idea for them, okay? The last thing I want to talk about is the hippocampus. And so the hippocampus is right here next to the amygdala, and basically it's in this region here. It's very strongly associated with memory, and people that have been traumatized and PTSD often have damage to this tissue. And what can happen is, let's say during that trauma, a person, there's like a certain expression of light outside, or there was a certain cologne in the air, or there was a certain food they smelled, or a tone of voice. And they're just walking around and that light, the same light hits their eyeball, and that same sound hits their ear, the smell. And the hippocampus starts freaking out, and it tells the amygdala that now I'm back in that moment, and that's like a flashback. And now they've lost time and space. They can become dizzy, disoriented, and they feel like they're in that moment, and they have an all or none fear response, a panic attack, basically. And that can become very debilitating, and now they live in dread of the next panic attack, okay? That becomes a big deal as it relates to blood in the intestines and the stomach long-term and the ability to heal, okay? Now, the goal of today was to talk about fear and how it manifests neurologically and how a person can end up with an overactive amygdala and projections to these different areas and how we can start looking for that and treating it. One of the most common causes of an upregulated amygdala, in my experience, that often isn't addressed is attachment issues, okay? Our hippocampus and temporal lobe really doesn't develop much until later on. That's why we don't have memories of our birth, okay? And so if we have a parent that is doing their best, but we develop a maladaptive attachment pattern with them, we can end up a dismissive adult, or we can end up a preoccupied adult or traumatized in our relationships with people. And if you're dismissive, you're vigilant about keeping people at a distance. And the amygdala is upregulated, saying, no, I don't want people to get close. I'm afraid of that, okay? The preoccupied person is vigilant about getting close or understanding, why am I isolated, okay? And then they may be upregulated amygdala, trying to figure all that out because we're hardwired for human interaction, okay? The traumatic person, they don't know what to make of it. Sometimes they're hypervigilant about staying away. Sometimes they want to get close. They're all over the map, okay? And those psychological patterns will reinforce the imbalances in this system, okay? And so often what I find is that people with specific patterns of trauma in their history comes up during the history, or particular relationships with their parents were troubling, or with their former spouses or current spouses have been very troubling. We start to see these attachment issues, and sometimes they respond really well to therapy. The people that aren't responding, they need their brain stimulated so they can actually respond to the therapy. And once they respond to the therapy and their brain is stimulated, the amygdala calms down, and now they can actually heal their gut. It's a pretty cool thing. So when we think about it that way, can you see how so many people really have no chance to get fully recovered by taking a loculated, singular approach, just looking at diet and just looking at supplements? to heal the gut and autoimmunity, because if we're polarized to this sympathetic tone and we can't regulate our own autonomic nervous system, then it's just going to be like throwing spaghetti at the wall and hoping that it sticks. You know, it might stick for a while, but eventually it's just going to fall off, okay? So this is part one in a series, and what I'd like to do is I'm going to talk about I'm going to say one more concept here, and that is serotonin, glutamate, GABA, alpha ligands, RH, okay? These are different chemicals in the brain that we can manipulate to affect this system. And so what I'm going to talk about in part two is how we can use forms and how we can use dietary analysis, and we can use history to evaluate which of these chemicals are deficient and or in excess. A big clue is if, for example, a benzodiazepine works, then that might mean that the GABA circuit is offline. So as a clinician, a person with digestive disturbance who has a history of social anxiety, who also has a history of agoraphobia, who, when we look at their intake form, has serious blood sugar issues, and we look at their labs and they're pre-diabetic and anemic from malabsorption for years, they don't have oxygen in their brain, now all of a sudden they can't make GABA because they can't run their energy cycle. And GABA neurons are not there to inhibit the amygdala, so normal, trivial stuff just brings the amygdala to threshold. And so that's the person where little things become big things, and they're always nervous no matter what they do, okay? And they could take a benzodiazepine like Xanax or Ativan, and they feel awesome, okay? But when the drug runs out, they feel terrible again. But the cool thing is, for a lot of these folks, there is a solution to that underlying neurochemistry problem that may not require medication for the rest of their life, because it actually addresses the underlying metabolic and neurological sequelae. So we'll get into GABA, we'll get into glutamate, we'll get into serotonin, we'll get into some of the other medication approaches. And then we'll also in the future talk about, instead of talking more about fear, we'll start talking about worry. And worry actually is a different circuit than the amygdala. It's related to the striatum and its association to the frontal lobe specifically. So worry can actually contribute to the exact same issue through a different set of neurons. And so that's a story for another time. Is there anybody that has any questions here before I say good night for the evening? Thank you so much for logging back in. I know that we had a little trouble earlier, but I'm looking forward to the next one. Okay, so if you need to get a hold of us here at Atlas Health, you can email us at contact@atlas-health.net, or you can give us a call at 415-459-4411. It's been a pleasure sharing this information with you. And if you happen to know somebody that is struggling with chronic autoimmunity, digestive disturbance, or PTSD, anxiety, things of that nature, and are looking for answers, please share this with them. Thank you.